Hi, I'm Brooke.
And I'm Tanner, and Chris is filming, and we did our project on z-test procedures. Steps to solving your problem. First, you want to identify the population of interest and the parameter you're trying to draw conclusions about. Then state the null and alternative hypothesis given. Choose the appropriate inference procedure, and make sure that you have all the conditions necessary to use that procedure. Third, if all the conditions are met, carry out the procedure by calculating the test statistic and finding the p-value. Finally, interpret your results.
These are the formulas needed to carry out a Z procedure. The null hypothesis is represented by mu equals the given mean. The alternative hypothesis is represented by mu is greater than, less than, or not equal to the given mean. Z is equal to x bar minus the given mean all over the standard deviation divided by the square root of n, and the p-value equals Z is greater than or equal to Z.
We will be doing exercise 10.39, which is titled Filling Cola Bottles. Bottles of popular cola are supposed to contain 300 milliliters of cola. There are some variation from bottle to bottle because the filling machinery is not perfectly precise. The distribution of the contents is normal with standard deviation sigma equals 3 milliliters. An inspector who suspects that the bottle is underfilling measures the contents of 6 bottles. The results are 299.4 milliliters, 297.7 milliliters, 301.0 milliliters, 298.9 milliliters, 300.2 milliliters, and 297.0 milliliters. The question we are trying to determine an answer for is this convincing evidence that the mean contents of cola bottles is less than the advertised 300 milliliters?
Alright, the first step in solving this equation is to find the null and alternative hypothesis. The null hypothesis is mu is equal to 300, and the alternative hypothesis mu is less than 300 because the inspector suspects that they are underfilling the bottles of cola. Step 2. Since we do know the standard deviation, then we are allowed to use the Z procedure. The sample comes from an SRS and has normal distribution because we are told so. Step 3. Z equals x bar minus the given mean all over the standard deviation divided by the square root of n.
Continuing on from step 3, we use the formula Z equals x bar minus the given mean divided by standard deviation over the square root of n. We know that the given mean is 300 and standard deviation equals 3 milliliters. Our x bar, the suspected mean, equals 299.03 and n equals 6 because there were 6 samples. We plug in the information to the Z formula to get Z equals 299.03 minus 300 all over the standard deviation 3 divided by the square root of n, which is 6. When we calculate this, the answer comes to negative 0.97 over 1.225. Plug that into the calculator to get negative 0.79184. Since Z equals negative 0.79184, we look that up in Table A, which has all the Z values. This will give us our p-value, which equals 0.2148. And because we're testing mu less than 300, we're going to do less than the given Z value. Our Z value is negative 0.79, and we're testing everything less than that. Our p-value again equals 0.2148.
For interpreting our results, we are testing this hypothesis at the 5% significance level. Our p-value is equal to 0.2148 or 21.48%. 21.48% is not less than 5%.
Duh.
We failed to reject the null hypothesis and have to accept it. There is not enough evidence to reject the null hypothesis because our p-value is not less than 0.05.
On the other hand, if our p-value was less than 0.05, we would be able to reject the null hypothesis and accept the alternative hypothesis. We would have strong evidence against the original mean or the given statement. In this problem, we do not have enough evidence to reject the null hypothesis. We must accept the null hypothesis.